session is Divide and Conquer, Send Forth the Microservices. So we're going to be talking a lot about Java and microservices. My name is Jennifer Reif. We do have a somewhat limited time, even though 55 minutes-ish seems like a huge amount of time for this. We're going to do a lot of live coding and a little bit of background. So I hope you brought your questions for the end. I'm happy to stick around and answer those. But if you think of something after the session's over, or tomorrow, or next week, or 3 months down the road, feel free to reach out to me. I'm more than happy to talk tech and geek out on that. So feel free to ping me. Any method you're most comfortable with is perfectly fine. So I am around and available. So a little bit of background on me. I'm a developer and developer advocate at Neo4j. I like to learn. I like technology. I like to learn technology. And then I somehow like to take what I've learned and share that with other people, hopefully to help encourage them or show them the way that I've learned something in hopes that maybe they could avoid some of the same mistakes that I made starting out. So I do that through writing blog posts, creating videos, speaking at conferences like this one, and I'm super excited to be here at Devnexus again. It's been, I guess, 3 years since I've been last. So. And then I do have other hobbies outside of tech. I like to kind of bring that passion across to other things as well. So that's just a little bit of side knowledge background on me. Again, I'm more than happy to answer questions. My contact information's there, and I'm almost positive I put it on the last slide too, but feel free to come up and grab me if not there. So you'll notice a little bit we're talking microservices in Java. I'm from Neo4j. A little bit of a disclaimer, I'm not actually speaking specifically to Neo4j today. So if that's what you came for, catch me afterward. I'm more than happy to dive headfirst into anything Neo4j. We are a graph database company that's doing a lot of really fun and cool things with data. But today we're going to focus in on the microservices and Java side of things, and then with hopes of eventually bringing Neo4j into the mix in the next couple of iterations. So first, to understand microservices, we need to know microservices is a somewhat newish trend, I guess, but we need to know where microservices came about. What kind of caused them to be brought into the tech industry? Because most of the time when you have a kind of a trend or a new system architecture, it's going to be derived from something painful that was already existing, right? So monoliths typically bundle things into a single application, lots of functionality into a single app. Either they were designed intentionally that way, or they've kind of morphed that way over time. So you may have had a small system, and all of a sudden it's like, oh, let's add this feature. Oh, let's add this capability. Oh, let's bundle in this application into this one. And then all of a sudden you have this massive app that is really clunky and hard to deal with. If you noticed my t-shirt or recognize the image there on the slides, you might recognize that as a picture of Helm's Deep from the Lord of the Rings movies and book. And I like to kind of think of a monolith as kind of Helm's Deep. The storyline, the king's kind of group that he was bringing along, their whole goal was, I'm going to take my people to Helm's Deep because the wall has never been breached. Nobody can break through, right? This is safe, nothing will happen to anybody, we've got this. And then all of a sudden what happens at the Battle of Helm's Deep is they break through the wall. Now what? Now your big fortress that was so strong before is all of a sudden crumbling and has a weak spot, and now you have some problems, right? So this is kind of the idea of a monolith. You have this massive fortress that's super well protected, it's big and imposing, but what happens when you have a breach? What happens when something breaks? All of a sudden your whole system, this massive big thing, is now crumbling or has a weak spot, and now you might have enemies or bad things on the inside, and it's hard to get rid of past that point. So the pros of a monolith is that you have one jar, you deploy the one jar, you mess only with that one jar, you don't have a bunch of other things going on. And there's less communication between your functionality. So your payment system and your order system and your logistics system, if all that's bundled, you don't really have to do a whole lot of coordination on those systems talking back and forth. The cons of that is trying to find and reuse code in this massive application can be pretty daunting. And when you try to implement fixes, you're kind of just pointing and clicking and hoping you don't cause breakages further downstream, right? Impacts and other problems. The other con is that you end up using a lot of resources. and handling failures can be a little bit tricky. Again, you're talking about this big fortress. If something breaks, all of a sudden your whole system is down or your whole system has problems versus just a piece of it. So this is where monoliths they started out, and then all of a sudden people kind of saw the pain points and things that really weren't working, and so they kind of came up with microservices. What are those? These are really small applications, typically are limited or single functionality based. And then they just communicate the necessary data between your services. So if your payment system talks to your order system, they may only send little bits that are necessary between those two systems. The good things about this is they're very independent applications. You have a very small footprint. You have a tiny little application. It also means that they're a little bit more reliable, because again, if something breaks, you just kind of spin up another one in its place, or you have other services that are still running and managing other pieces of the system while you're doing kind of fixes and working on that one. It also means they're scalable, so to handle resource load and things like that, you can spin up one section of the application without impacting anything else going on. The bad thing on microservices is testing can be a real pain. So unit testing, integration testing, now you're dealing with lots of different services that all of a sudden have to communicate back and forth to one another, and you have to coordinate those. This one service is dependent on this service being up and running, and all that sort of stuff. So, and then the other thing is you're adding an additional layer and some operations cost. So the additional layer is probably going to be like your communication or your architecture layer to say that these all services kind of are grouped under one, and you have to manage those and coordinate those, and that just adds an additional layer. So I like to think of microservices. We had the image of Helm's Deep and the big fortress. This is actually a battle strategy plan for the Lord of the Rings. So you can see all the little battle units that are kind of all over the place. And this is more what a microservices architecture kind of deals with. You're talking smaller units, you have this little skirmish here and then one over here, and it's all broken up into pieces, and so you have less maybe failure rate, if you will. So just a disclaimer before we charge into other things, monolith versus microservices. I'm not saying you must do this, you must do that. Neither solution is going to be a silver bullet. No matter which solution you choose, you're going to get some things that are going to be super simple and other things that are going to be super complex in the same solution. Also, beware if you do choose microservices, depending on who you're talking to, what business you're talking to, their level of what classifies as a microservice could be totally different. So the scope of the functionality of a service, whether it handles 4 or 5 different functions or only one function, everybody's going to kind of have their different level of what classifies. Whether you're talking asynchronous communication or synchronous communication between your services, a lot of people only classify you must have asynchronous communication to be classified as a microservice, and the level of automation. How much is the operations person or the developer managing and handling and touching those services versus letting a tool do all that for you. So it really depends. When you say I have a microservices system, you talk to somebody else and they'll tell you that's not a microservices system, at least not the way they classify it. So do beware that kind of the scale of monolith to microservice could be totally different. And you can fall anywhere in between, that's perfectly fine. Just realize that the definition may be slightly altered. Okay, so we're going to talk now about what demo the architecture that we're going to build. So I'm starting way down at the base level here, and I've just used a MongoDB database. Now, again, you're looking at me like, you work for Neo4j though, right? Yes, I do. But when I started out, I really didn't know a whole lot about building microservices, but I knew Spring Boot. And so I wanted to create just a couple of Spring Boot applications. Spring Boot happens to have a very vanilla, kind of easy synchronization with MongoDB. So I started there with the whole goal that as I start building this microservices architecture, I'm going to be building other technologies, other data stores, and other functionality into this whole system. So I'm starting with Mongo. I have a book data set, a Goodreads data set, loaded into that database, and I'm running it in a Docker container. So I've already got that done, and if you want to know more about that information, how I did that, how I did the data load, and all sorts of stuff, I do have a blog post out there. So we're going to start there. I'll spin up the container for that in just a second when we get to the code. But then I have my database layer, and now I maybe want to create an API layer. So I'm going to create a service that's going to open up and talk books. So how many books do you have? Which books do you have? and it's going to pass data back and forth. So I create this API layer that then people can query REST endpoints and pull the data back and forth. But again, I'm not exposing my database directly. I'm doing that through a REST API. Now maybe I don't want to expose my API. Maybe I'd want to have other types of data stores, therefore a lot of different APIs for maybe authors or user preferences or user reader history and all sorts of things. And so I don't want people to have to query each of these APIs. And so I'll create a client layer or a client application that then the user can touch and interact with that service, and then it will handle all the requests to anything underneath that. So again, I'm moving my API and my database layers down away from the user, and they're just going to interact with service 2, or that client layer, and then it handles everything underneath that, depending on what I want to build into it. And then, so you're starting to see, I have a database layer, I have an API layer, maybe I'd want to build other databases in, other APIs in, and so I may have this huge amount of services that are going into this. And in order to spin all those up and spin all those down, that could be kind of tricky to do manually, right? So this is where I'm going to add something like an orchestration layer, things like Docker Compose, Kubernetes, things like that, to start managing my services all in one unit. So I'll create like a YAML or a basic configuration file that then it'll say, hey, I want these services up. This is what I want you to build in the configuration when you spin them up, and all that sort of stuff. And I won't do YAML coding for you. I won't make you fall asleep after lunch, but I am going to show you the YAML file and some of the little tricky things that I ran into when I was trying to put this together. So I will kind of give you guys heads up. And then if you have other questions about YAML afterward, feel free to come talk to me, but I won't bore you with that. Okay, so let's dive right into the code then. So we're going to go over to start.spring.io. So I'm going to build Spring Boot applications. Again, starting from a very kind of well-known thing that I'm comfortable with, but you can build any sort of application you want. You can build any sort of platform you want. Anything can be pulled into microservices. So my eventual plan is to use a little bit of Spring, to use a little bit of maybe some Quarkus, to use a little bit maybe other things as well, and build that all into microservices, because we're typically not platform specific, right? You're going to have lots of other things you want to bring that data in together. So I am going to start here with Spring Initializer. I'm going to build a couple of Spring Boot apps for my services. So I want to stick with Maven today and Java, stick with the stable release of Spring Boot, and I'm just going to call this, to kind of organize my stuff, and I'm going to call this service 1. Leave the package name, the jar, Java 11. We're going to stick kind of middle of the road for today. And then I want to pull in a couple of dependencies. Now, I'm keeping this relatively concise and small, so I need to have a reactive web, which is going to allow me to create RESTful services, so create those API and the endpoints in order to query those. And then I want to add Mongo, because I'm going to start with my service 1, which is going to be my interface to my database layer, which means it needs to read and talk to the database. So I need to include reactive MongoDB. Because again, potentially, I'm starting synchronous, by the way, synchronous communication between the services, but potentially with reactive, I could go asynchronous. So I could add in messaging platforms and things in between that then would feed data back and forth without waiting for a response back and forth. So I'll talk a little bit more about that when we dive into service 2, but we're going to start with just the Spring MongoDB. And then I'm going to shortcut a little bit of boilerplate today just for demo purposes and use Lombok. Everybody kind of has their own special thing, whether they prefer Lombok or not. That's totally up to you. All right, so we're going to generate service 1, and I'm going to dump this into a Devnexus folder. Oh, I did not clean that out. I'll have to do that in a second, or I could just save over it. So I have Maven Java. I'm going to stick with that, and I'm going to create service 2. So most of the things are going to stay the same. However, remember, my service 2 is my client layer. So it actually doesn't talk to the database at all. Therefore, it doesn't need to connect to the database, so I can remove this dependency altogether and just stick with my RESTful API dependency and Lombok. And so I can generate this. And yeah, I'll just drop that right in there. And then let's switch. I don't have a Finder window open. And let's go to my downloads. And I didn't clean this out yesterday, so 1 second. I did test all this yesterday, so if I haven't messed anything up or the demo gods haven't ruined my foo, then I should be okay. All right, so let me open my service in IntelliJ, and we'll start with service 1, and I'll fix the font. Give me 1 second. I usually try to do this beforehand, and sometimes I forget. And then editor, font. Okay. Let me load that. How is that for everybody? Halfway good? Okay, cool. All right, so this is just our POM. So this pretty much tells us everything we already know because we built this into our start.spring.io. So we have our dependencies of reactive Mongo. We have our reactive web, which is going to allow me to create REST, and then Lombok. And then we have our test starter and our reactor test dependencies in there too that get dumped in there automatically. So first off, I want to be able to connect to MongoDB. So in order to do that, we know we have 2 services running, and in order for communications not to get kind of mixed up or crossed, then I'm going to include a server.port, and I'm going to set this application to run through port 8081. So all communication that needs to go to this application is going to access port 8081. Then I also need to create the connection details in order to access MongoDB. I set up my Mongo instance with a username and password. And so if I type in, I want the URI, MongoDB, and then I'm running this locally, which I still need to spin up my container yet. But then I also put in username and password. So I made it use authentication. So in order for me to add that in, Mongo admin, and my super secret password there. And then where it could find it and the port number. So that is the default Mongo port, 27017. And then I'm also going to tell it which database to connect to. Because with MongoDB, you can have multiple databases in a DBMS. All right, so that should allow me to connect to the database. Now I need to go up and mess with my application here. So first off, I know I'm dealing with Goodreads data. Now I wouldn't have to map that to a domain model necessarily, but otherwise I've got this ugly map of objects and this and that I have to try to render or piece apart. And so to make that easier, I'm just going to pull all of my data that's coming back from MongoDB. I'm going to create a domain class to kind of map that, make it a little bit easier. Now I'm dealing with Lombok, so I'm going to include the @data annotation, which is going to go ahead and build some of the boilerplate for me, getters, setters equals hashcode toString, so that I don't have to clutter or add extra typing in today. So that's going to handle that. And then I also need to tell it that this is a Spring Mongo entity. So Mongo deals with entities in document format. And so to tell Spring that, hey, this is a document entity for MongoDB, I'm going to use the @document annotation. Then I need to say which field is going to be an ID field, and then private string. I'm going to call this Mongo ID. Mongo creates this kind of internal generated ID field down in there, and so I'm going to reference that and put that into a field as well. You wouldn't have to. And then I also want to use another Lombok annotation that says, hey, we don't expect this particular value I'm going to provide next to be null. And this is going to be a book ID that got pulled from the Goodreads data set. And so I want to make sure that that's not null, because that's the primary key or the primary identifier of the data set I pulled in. And then I'm going to keep just a couple of other fields on here. And I could actually create all of those into a single line, but just to keep it easy to read, I'm going to do title, format, the ISBN 13 for the international, and then edition information. So which edition is this, etc. Pardon me. Okay, so there's our data entity, our data class. Now we need to create an interface that is going to allow me to use methods that interact with the database and pull data back. So I need to create a book repository, and then I'm going to extend the reactive CRUD repository, and I'm using type objects of book, and the ID for those objects are strings. And then that actually is all I'm going to create. So Spring has this kind of nice, neat feature where it has these default methods for anything that people do all the time, like find all, find by ID. Most of those implementations are going to be pretty the same across the board, right? And so Spring is actually going to provide those out of the box for you. And then if you need to customize those or you need to write your own custom queries, you could absolutely do that. But we're just going to stick with kind of out of the box stuff for today. And then I need to create a book controller. So this is going to be our controller class that basically sets up the REST API for us. And I need to specify this as being a REST controller and set up a mapping, an endpoint basically for us to hit. So I'm going to use this as our DB endpoint. So this is the connect to the database. And then I need to use a Lombok annotation to create a constructor with all arguments. Okay. Of course, I would get something in the back of my throat while I'm trying to talk. I want to inject our repository first. So book repository, like that. And that's going to let us access from the controller the methods in our interface, which of course is just the default ones right now. And then I actually can start defining some endpoints. So I didn't used to do this particular endpoint. However, I had a few little issues with the Docker Compose stuff. And so after that, I started doing this. Sorry, that was bad feedback. So service 1 is up. So this basically just very, very simple. It's going to create a mapping that say, hey, when you call /db endpoint, it's going to return a string that says, hey, service 1 is actually up. And then I'm going to create a mapping that's going to go to /books. And this is going to pull all books for us. So I'm expecting a flux. So you have a couple of reactive types you can return, either a flux or a mono. A flux is 1 or more, I believe, and then mono is 0 or 1, the items that you're expecting back. So in this case, if we're going to get all books, we're probably expecting multiples. So a flux of books, and we're just going to say get all books. And then return book repository.findAll. And again, I did not define that method at all. It's just provided for me. And then I'm going to do one more to get a particular book. So /book/ and I want to provide a parameter here. So Mongo ID. And then we're going to expect a mono, a single book probably back. Like that. And let's say get book by ID. And we're going to path variable, string, passing in the Mongo ID as part of the endpoint. Return book repository dot find by ID, Mongo ID. Okay. So that sets up our endpoint really nicely. We can run this. Of course, I need to spin up my container. 1 second, because I didn't start up my Mongo instance. Okay. And then we're just going to do, and I've got this already in the container's already been run a few different times. I had to start it up. Okay, so now let's go back over to our service 1. And we should be able to run this. And it will interface with the database container that I have running locally. And then we should be able to hit our endpoints and see the data coming back. So this will tell us, okay, we are able to connect to the database. And that's looking good. So let me bring this up a little bit so everybody can see better. How's that? And then, so I'm going to hit the endpoint. Remember, our container is running on port 8081. And we're just going to make sure that, 1, the application is up. So indeed, we have the string coming back. Service 1 is actually up. So our application's running. Now let's see if we can get some books back from our database. And taking a second, because I've got about 10,000 books or so sitting in my local database here. So you can see we've got all the information coming back. We've got the book ID, the edition, which there's an edition 2 up here. And all of that is looking good. We've got a bunch coming back. Now I could even just pick a particular book here. Like that, and we see we get a single book back. So all of our endpoints for our REST API are working and running. That's awesome. Now let's take it one step further. We've built our API, our REST endpoint, our REST API. Now we want to build that client application on top. So let's switch back over to IntelliJ, and we'll leave that one running, but I need to open up, actually, service 2 here. And I'm going to do the same thing here. And our POM, we're expecting our web, and remember we don't have MongoDB as a dependency, and our Lombok, so all that looks good. And then resources here. So remember, again, we have two applications. We need to specify a particular port. Now, over here. Now, if you notice, you'll see kind of a light gray default 8080. So the default port actually for Spring is 8080. However, just for clarity, people looking back at application code, I am going to go ahead and just spell it out there, just so it's easy if people are looking back at code later on. So you wouldn't have to specify this particular property. And then I'm going to open up my Service 2 application. So this is a client layer application, and we're going to interface with our REST API layer. But maybe I want to interface with that a little bit asynchronously via HTTP, so a little bit reactively. In order to do that, REST API is a synchronous communication, but HTTP is not. So we're going to create a bean, and we're going to use the web client. And of course, it's not finding it. Why isn't it finding it? Okay. Create class. Why isn't it finding that? Come on, IntelliJ. Let me make sure. Check my POM. Did I not choose reactive web? Let me go back and look. Oh, I didn't. Oh, that's going to be problematic. 1 second. Yeah, reactive web, that's what I want. Okay, and excuse me for a second. Gotta fix that. So I'm just going to pull the dependency really quickly for reactive. You know, I should be able to pull that up in IntelliJ. 1 second. Starter. Reactive, come on. All right. Then we're going to pull the dependency straight from here. So I am going to do this. Okay, 1 second. And the troubleshooting has already begun. All right, so I'm going to open that up, and then I'm just going to open this and... but I think in my service 1 POM, I also have just plain, because I didn't change that dependency. So I don't think I used reactive there either. I think that was my initial problem, is I chose the wrong one. I will check, though. Let me... okay, so it should be this one here. Starter WebFlex, okay. And then run Maven, and then let me flip window over to service 1 here and check my POM. Yeah, I didn't use the reactive here either. I used the reactive Mongo. Okay, rerun that service. Sorry about that. Okay, so let's switch back. That's why it wouldn't recognize web client. So now if I do this, now I should just be able to import. Sweet, okay, much better. All right, so now I need to return. I'm going to webclient.create. So here I'm basically creating a web client bean that then I can access to pass data via HTTP requests. Okay, so then my endpoint is going to be HTTP, and I'm running via localhost port 8081, because remember that's my service 1 endpoint. So I'm going to create a bean that's going to connect to my service 1, and then I can start creating my other classes here. So I want to create another book object so that when I get my objects back from my service 1, I can actually mapping that to something that's sensical. But I don't need to specify some of my other annotations that I did last time. So really all I'm going to do is use the data annotation. That's going to create my getters and setters so that I can access the fields that are inside this object. And then I need to create fields here for MongoID. And again, my book ID here. And then the title of the book, the format, the ISBN 13, and the edition information. Okay, so that looks good. I don't need an interface, because again, I'm not interfacing with the database, but I am going to need a controller. So I'm going to call this a client controller. You can name it anything you like. And then I'm going to specify this as a Spring component. This is a REST controller component. Need my request mapping, because again, I want to be able to hit an endpoint that the client can use to access the service. And I'm going to call this Goodreads, so they can go to /Goodreads in order to access this info. And then I'm going to create a constructor with all arguments, or Lombok is for me. And then I'm going to inject my web client bean here, just call this client. And then I can use that in order to get a couple of endpoints. Now again, I'm going to create just an endpoint that's going to return a string to make sure that my app is actually up. So it's not going to hit the database or anything specific. And client, and we're going to do a get, because this is a getter, not a write function, not a put or post. And then I'm going to specify a particular URI, because remember, the localhost 8081 is just to hit the application. So I need to specify, I want it to go to /db/books. And then we're going to, where is it? URI dot exchange to flux. Dot retrieve, that's what I want. I want to retrieve, and I'm going to convert that body to flux and book.class. So basically what it's going to do is it's going to take, it's going to do a getter from that URI. It's going to retrieve the information back. And remember, this is an HTTP request and response. So with the response, it's going to take the body of that response and to convert that data to a book object, a flux of book objects, body to flux of book.class. And I don't know why it's red. Silly, silly. What doesn't it like? Flux. That's, silly me. This is I got ahead of myself. That's what I did. Okay. All right, so we're going to return service 2 is up. Okay. Now we're going to create our endpoint for our books. Sorry about that. All right, so /Goodreads/books. And then we're going to expect a flux of books. I can type. We're just going to say get all books, like that. And then I can paste that in. Okay, much happier. This is what I get for getting ahead of myself, getting flustered over my dependency thing there. Okay, so now we should be able to run service 2. We've got service 1 already up and running. We have our database up and running. So now if we run our client application on top, I should be able to hit port 8080 /Goodreads/books in order to get basically the same information I created in my REST API. But now I'm creating that client layer. So let's go back to here, and we're going to do HTTP port 8080 /Goodreads. We're just going to make sure that service 2 is up. Indeed it is. So now we can do our /books endpoint, and it should go via service 1 back to the database and return books, which is what we have. Now this is great. We've got 2 applications, we've got a database and a container, but we're running this all locally. And imagine again if you had multiple databases, multiple services up and going, that's really kind of a pain to hit start, run, stop. Okay, this isn't working. So what I ended up doing was creating a Docker Compose file. And so I'm going to open that up, and I created just a base level Docker Compose, and I'm just going to open this with Visual Studio Code. I'm a little bit tool agnostic. I like IntelliJ for certain things, and I like Visual Studio Code for certain things. It all kind of depends what I'm doing. So, okay. So there's kind of some variability with what you include, but I need to define my services that I have. So remember that I have a Mongo container already running locally, but maybe I want to let Docker Compose manage that for me too. So I've created a DB service, and I'm going to have a container name. I'm just going to call it DB. And then the image I'm going to run off of, I do have a image sitting out in Docker Hub, so I'm going to let it just pull the image from there. I've set up some environment variables for my username and password to get into the database. Then I need to map container ports. So 27017 is the default port for Mongo, and I'm going to map my container port to my host port, 27017 to 27017. So all traffic's going to be handled through there. I'm going to create a separate network, and this was one of the things that I had trouble with because normally if you don't specify a network, it just creates a default network. But that means that your containers can only talk via IP address. So you have to reference the IP address of the other container in order to pass information back and forth. If you create a custom network, then it can actually reference the container by container name rather than IP. Of course, it depends on your setup and all that, but just for my sanity, I like not to reference IP addresses and go with the container name. So I created a network that I've actually specified down here at the bottom. Oh, I called it demo, so I'm going to do that. Just call this, use my demo network. So the container is going to spin up on a kind of a lone solo network called demo. I'm mounting some volumes so that I can keep track of data and the database and all that sort of stuff. Not really a big deal. If you're familiar with Docker, you'll probably have done that already. Then I've got my service 1, and so my container name is going to be service 1. And then what I want to do is, you can pull from a Docker image on Docker Hub, but what I actually want to do is I'm going to let it build from a Docker file that I'm going to toss into the folder itself. So you can actually tell it to dynamically build based on a particular Docker file you have locally or somewhere else. And then I'm going to have it use, just call that service 1 so that I can use that, reuse that same image later if I want to. The port here, remember service 1 deals on port 8081, so I'm going to map the container port to the host port there. And this is going to depend on the database. So remember, service 1 connects to the database. So if the database isn't up and running, then I really don't want service 1 up and running either. And then my environment. So remember, I specified the database credentials here. And so I'm going to do basically that same thing here, MongoDB, local. But remember, we don't want localhost, because now we're not running locally. We're running on a Docker network somewhere on my machine or somewhere else that you may have specified. So we actually, remember, we can specify to connect to the container via container name. So that's what we're going to do here. And then container name 27017. And then, of course, I had login credentials. I'm going to specify those here like that. And then the database on Mongo is Goodreads. Networks, I'm going to use that demo network again. And then basically the same thing with service 2. Oops, service 2. And build, I'm going to build the Docker file that I'm going to toss into the service 2 folder in a second. I'm going to call that service 2. And then the port, remember we're dealing now with 8080. And it's going to depend on service 1, right? Because remember, if service 1 is not up, we don't want service 2 to be running either. Of course, you could change and tweak that. Now, there's one other thing, because remember, if you remember our service 2 application, we created a web client bean that went to localhost port 8081. Obviously, that's not going to work when you spin up a container on its own little network. So what we're going to do is we're going to create a backend or an environment variable, a backend hostname environment variable that it's going to toss into the container and then therefore read that as configuration and say, okay, when you're not running locally, we want you to use this environment variable as the host name instead. And so we want it to use service 1, because remember we can reference container name. And then network, again, we want to be consistent here. And that should be everything in my YAML file. Now, I need to go back to service 2 really quickly and change where it accesses that host. So you can see we have localhost specified here. What we're going to do is use an app value annotation, which is going to allow us to kind of create a dynamic value. So here, we're going to specify lookin for backend.hostname. Remember, environment variables are all caps underscores, and then within Spring, they're usually lowercase and dot separated. And if it does not find a backend.hostname environment variable, then just use localhost as the connection, like that. And then we're going to put this into a hostname variable. And then here, we're going to cut this out and use hostname in the middle there. So basically, it'll look for that environment variable. If it doesn't find it, it'll just go to localhost. So no matter if I'm running locally, if I'm running on Docker, if I'm running somewhere else, I can specify that configuration outside of the container itself, and it'll still look for and find that dynamically. So let's go ahead and stop this for now. And then do the same thing to service 2, because I'm actually going to spin this up inside Docker now. So stop that. And then, got that specified. Oh, I need to drop in. So I did create a slight little cheat sheet. I have a Docker file that I've already created, and I'm more than happy to explain these. They will be out on GitHub, but I'm just going to copy these in for now, just so we don't have to build a Docker file from the ground up. And paste these into each of our services. Because remember, I'm going to build the Docker container on the fly. paste. Okay, now I should be able to go to my terminal window and go to downloads like that. And I called that folder Devnexus. Okay, and now I'm going to go into service 1, and I'm going to do a Maven clean package, because what my Docker file is going to do is it's going to build a jar file, or it needs to take that jar file and put that bundled application and drop that into our Docker image, our Docker container. So I need to build that jar file really quickly, and then Docker can pick it up and dump it into the container. So when that runs, then I'm going to do the same thing for service 2. Like that, build the jar file there, and then I should be able to run Docker compose up, and it should build the containers for me, spin all the services up, and then I can hit my endpoints again from outside. Okay, now I should be able to do, cross all fingers and toes that this works, Docker compose up -d, so I'm going to detach, it's going to run in the background, and I'm going to, you can, if you don't specify build, it'll just build the containers initially, but if I need to like stop it and restart it, then it's not going to rebuild those images. So if something were to go wrong with my Docker containers and my applications, I like to just put the -- build so it's consistent all the time. So it'll build my Docker containers. You can see it kind of doing that. Oh no. Oh, right. Okay, so I still had my Mongo Books Docker container for Mongo up and running. So now I do the same thing, and that -- build is needed now because I do need to rebuild my applications. All right, there we go. So now if I do a Docker PS, cross fingers, yes, all 3 services are up and running. So I have my database service running, maybe a little bit hard to see. The database service is down there on the bottom, the JM Reif MongoDB. I guess I can highlight it here. So this, and then I have service 1 here, and I have service 2 here. So now I should be able, and these are all running in Docker containers, the applications are running. Let's hit the applications and see what we got. So 8081, let's start with our service 1 REST API layer, database endpoint. Okay, service 1 is up and running, that's good. Let's check 8080/goodreads to check that the service 2 is up. Okay, that's looking good. Now let's try to return /goodreads/books. And remember, this is from service 2, this is our client. It's going to hit the service 1, which is then going to hit the database and bring books back to the client. So cross all fingers that this works. Yes, okay. So now we have everything running in Docker containers. We've spun it up using Docker Compose. It spun up all 3 containers. We can still connect from the outside and hit the endpoints and retrieve data back to us. And all I had to specify was a Docker Compose up. And it spun all those services up for me. And I can actually do a Docker Compose down, and it's going to spin all services down for me, so that I'm not having to start and stop individually. Might take it a second. There we go. Okay, and now if I do a Docker PS, you'll see nothing's running now. So it handled all of that for me using Docker Compose. All right, so let's dive back into a couple of slides. We've got a few more minutes. So as you can imagine, this is just the start. Right? We've only built a couple of services. We have only a couple of endpoints to just look at books. Where could we go from here? So Polyglot, most of us don't deal with one single database, right? My hope is to start adding things like Neo4j and recommendations for books or user preferences for books and authors and so on. So creating kind of this polyglot environment where you have multiple databases. You could do something like asynchronous communication using message brokers, things like Kafka, RabbitMQ, and a whole bunch of others. Doing more on the orchestration front. So I just did a kind of a baseline example of Docker Compose, but Kubernetes handles a whole lot more and usually a whole lot more complex systems out there. So diving more into the depths of what you can do there. Testing, we didn't even cover testing. So unit and integration tests, we're making sure that all services are up and running. Scaling and monitoring using tool suites in order to spin down or spin up broken services and handle the scaling and the load resources there. And then deployment, we didn't deploy to cloud. We did all of this locally. So we could deploy to things like Azure or GCP or other sorts of cloud services in order to run those containers and those applications and handle all that dynamically. So this is really just the start. If you're interested in more information, check out the code. Everything that I've built today is available on my GitHub repository. This is the meta repo. What we covered today was the level 5 link that's on there. But I have everything up till that point. So I started at a very base, just pass a string between 2 Spring Boot apps, and I've built everything all the way up to multiple services in the Docker Compose example we looked at today. I cover all of this in more detail in my blog, so if you want to review what we covered today, or you want to know more, or past iterations that I've done on this project, feel free to check out the blog and keep an eye out for anything coming as I start building more microservices and more complex systems. And again, if you're interested in Neo4j, there's a link there that'll give you access to a cloud database for free. And so you can spin up and look at a graph database and the data and how it's going to operate. And then hopefully I'll be bringing that into my microservices project here in the upcoming posts and code examples. So again, feel free to contact me if you're interested. My information's down there. I'll stick around here for a little bit to answer questions, and we do also have a booth that is right down in the lunch area if you haven't already seen us. I'll be down there a little bit afterward. Feel free to come by and catch me there as well. Ask me tech questions or microservices project questions or Neo4j questions or anything on your mind. I'll be around and available. So thank you all so much for coming, and I hope you enjoy the rest of the conference.